Hey guys, so for my final project for this course, I'm going to be trying to predict the prices for secondhand cars. Uh, we're going to be doing that using supervised machine learning models. And the aim of this project, of this notebook, is to basically help potential customers be better prepared in their search for a secondhand car by having a better understanding of the market, a better estimation of the price. And on a personal level, this is going to be a learning experience for me to see to see how to do EDA, how to train models, which models to do, how does each model react to the data, how efficient a certain type of model will be to certain type of data, and so on and so forth, right? So it's going to be a learning experience. So I'm really excited to get started. So in this particular notebook, we're going to be doing the following steps. We're going to get the data, clean the data, perform EDA, train a couple models. We're going to be evaluating those models and compare those two models. So hopefully we can learn something from there. The data, so I got the data from Kaggle. It's called a used car price data set, right? And this has 1,552 rows and 15 columns, and has car name, registration year, insurance validity, fuel type, and a few other important and useful attributes, useful columns, right? And as far as machine learning models are concerned, we're going to be using two models, a linear regression and an ADA boost regressor. I chose these two for the diversity, right? So we can leverage the strengths of both the linear models and an ensemble model method, and this will help us understand the data better, understand the impact of linearity and non-linearity in the data, right? That's one of the main reasons for this. And I also chose this so we can compare the two models and validate the two models and see how each model reacts to the data, how efficient a particular model is to the data when used on data, right? So that's the reason why I chose the two models. So let's get started. First, we load the data here, and as we can see here, these are the columns, and these are the null values. As we can see here, there are a few null values over here. These are the non-null values, but we can see compared to the others, there are some null values. So we're gonna check here, and as seen earlier, there are some null values. We're gonna do some deep dive into this, and as we see, the null values are basically just these four columns, just these four rows, and we're gonna see. And it does look like it's just these two type of cars, and for these two type of cars, it's just these four rows that contain the null value, so we can safely remove them, as this will not impact the data in any way. So as we can see, there are no null values over here now, and we're going to delete the registration year column because it is redundant, I believe, with the manufacturing year. It's basically the same, so we're going to remove that. We're going to delete the duplicate data, and we can see that there's 1129 non-null rows remaining after removing the duplicate data. And what we're going to do now is we're going to create two new columns from the car name, from the existing car name column. So we're going to basically split it between the name of the company, the maker, and the model, right? As we can see here, that's what it is. Car model is S-Class S400, maker is Mercedes-Benz, for example. So we're going to do that, and as we can see here, we're basically describing it: the count, mean, standard deviation, minimum, maximum, and all that fun stuff. And this is the description of the object columns: car name, insurance validity, fuel type, etc. Right? And we're basically listing the top 10 car makers over here, and we visualize that over here. And the next thing we do is something different, something interesting. What we do is we're basically going to map each of the car companies to the country of origin, right? We're going to be mapping that because I do believe that this is going to provide some further insight. When we get to the machine learning model, when we get to training the model, I do believe this is going to provide some deeper insights, interesting insights. So that's what we do here. We're going to we basically visualize it. Here's the spread, and we see that here's the spread. India has 325 cars. This is basically because this data set is from India, so Indian cars obviously have the most have the most number of cars, as we can see. And next we're going to go through each one of the columns. We're going to check for corrupt data. We're going to check how it is. We're going to maybe look at what the outliers are. For example, we're going to clean the data, right? First, right off the bat, we're going to do. I'm just going to talk about this one. For example, right. Right here for the insurance validity column, we see that there are two values. One is third-party insurance and third-party. These two values should be the same. They are the same, but they're two separate values for now, right? So we're going to merge those two together, and next we're going to see that there's patrol and there's not available. Not available technically is fine, but patrol as insurance validity is wrong. So we are going to be deleting that value. So this is the type of analysis that we're going to be doing for all data for the other columns as well. Fuel type is fine. Number of seats is fine. Kilometer driven is fine. There are a couple of outliers, but I do believe it is in the real world. It is practical to have cars with that much kilometers driven, right? And we can see ownership. Ownership has a lot of corrupt data, and we're going to be removing all those corrupt data because ownership is, first owner, second owner, third owner, fifth owner is fine, but CC, this is engine values. We're going to be deleting all these rows because these are corrupt, right? And now we can visualize the ownership values. It is fine. It looks good now. And yeah, we can see here as well, there's 11, after removing that, there's 1100 rows. Transmission is fine. Manufacturing year looks fine. The engine CC, mileage is fine as well. Next we see engine CC, right? Engine CC, there is a couple of outliers, and these outliers are huge, right? So we're going to be deleting some of these outliers because I do believe that any second-hand car with an engine CC of greater than 8400 is wrong. I do believe that because when we're talking about second-hand car markets, 8400 cc, that is pushing it. I do believe that. So we're going to be deleting any rows that has engine cc greater than 8400, right? So we're going to be deleting all these rows, and we're going to look here. There are a few outliers, but it's fine. Next, max power BHP. We're going to follow a similar logic over here. Anything greater than 300 horsepower, we're going to be deleting it. We're going to be considering that as corrupt data. Torque as well. Anything greater than 20,000 torque, we're going to be considering that as corrupt, and we're going to be deleting that as well. So finally, we have 956 rows after the cleaning. So next we have price in lakhs. As I said, this data set is based in India, so that's why we see the lakhs here. So for better understanding, 1 lakh is basically 100,000. That's the metrics. So 1 USD is 83 Indian rupees. So 100,000 Indian rupees is basically 1200 USD. So 17 lakhs is 20,000 USD. So that's basically what I'm going off of. Anything greater than 17 lakhs or 20,000 USD, we're going to consider that as corrupt, because knowing the Indian market, we get some really nice first-hand cars, brand new cars for 16 lakhs, 17 lakhs. So anything higher than that for a second-hand car is corrupt, in my opinion. So we're going to delete all those rows. So finally, after everything is done, we have 795 rows. After all the cleaning is done, as we can visualize the price over here. A couple outliers, but it's fine. Next, we're going to basically encode some of the columns: ownership, transmission, fuel type. We're going to be ranking them based on preference, right? First owner, the larger number is basically the best preference, right? So first owner is most preferable compared to third owner. Automatic is preferable to manual. Petrol is preferred to CNG. That's the idea I went with. And we're going to be dropping the car maker and car model because I do believe that compared to these two columns, the origin country will give a better insight into the data. It'll be more useful to training the model. I do believe that. So we're going to delete these two columns. So here's the numerical columns. Here are the categorical ones. For categorical columns, it's just these two. So what we're going to do is we are going to basically encode them and make them into binary. And make them into binary rather than categorical, right? As we can see here, that's what we did. We used the get dummies method of pandas to achieve this. And now that all the cleaning is finally done, we're moving to feature engineering. Here's a correlation matrix, and right off the bat we see that engine CC and max power, they're basically the same. All the values are basically the same. So this is what we call perfect collinearity, which means these two values are redundant. So we're going to be deleting the max power BHP column because it is redundant with the engine CC. So now we see the correlation matrix after deleting that. It looks fine. We're going to be splitting the data into training and testing sets, and now we get to the model training, right? So as I said earlier, we're going to be training two models and testing two models, linear regression, ADA boost regressor, and for feature engineering we're going to be using recursive feature elimination with cross validation for both the models, for both the linear regression and the ADA boost regressor. As we can see, here are the selected features. There are quite a bit of selected features for the linear regression, but when we get down to the ADA boost regressor, there's only 4. This might potentially be a problem, but let's see. So we train them, we fit the model, we train it, and then we evaluate the model, and this is what shows up, right? As we can clearly see from these values, right, especially from the R2 value, we can clearly see that linear regression is the better model, is the best model for this particular data set, for this particular data set, because it does follow a linear path. So yeah, as we can see, the R2 value for the linear regression is 0.708, but the R2 value for the ADA boost regressor is just 0.455, right? So saying that the linear regression is 70.8% better, or the linear regression explains 70.0% of the understands 78.8% of the data, right, compared to the ADA boost regressor, which understands only 45.5%, right? So so looking at this, the linear regression is the clear winner compared to these two, because the data set prefers the data set is better suited for linear regression. So as we can visualize the residuals for linear regression and ADA boost regressor. As we can see, once the price gets over 10 lakhs, the model does start losing it a little bit. It works better with values with price less than 10 lakhs, but for the ADA boost regressor, it's just off from the beginning, right? And we can see the predicted versus actual prices for both of it. As I said, right, after before 10 lakhs it works fine, but after 10 lakhs it starts losing it a little bit. But the ADA boost regressor basically had no chance from the beginning. So that's pretty much the project that I have worked on. Some of the key takeaways is the importance of metric selection, right? Because the reason we chose R2, MAE, MSE, RMSE is basically compared to accuracy, for example, right? Accuracy is better for classification models when it's yes or no kind of things, but for regression, especially for this data set, we want the predicted value of we want the predicted price to be as close to the actual price. We don't want it to be exact. I mean, we can be, but it's hard to be exact, and we're fine with it as far as this data set is concerned, as far as this project is concerned. But so that's why R2 value is more useful, is better at evaluating this model compared to accuracy, right? So that's something that I learned over here. That's a key takeaway. And the other is the importance of feature engineering, because as we clearly saw, the method, the RFECV method for getting the best features worked decently well for the linear regression, but it did not work at all for the ADA boost regressor, where we saw that there was only 4 features selected, which even to my eye it looked wrong. So maybe the next steps is basically to try different methods for feature engineering, especially for the ADA boost regressor. We can try to make the linear regression better as well, but it is a good starting point. We can definitely try to make it better, but the ADA boost regressor, we definitely need to try something else to make that better. And I do believe that 2 things we can try is feature engineering, try to find a different method to select the best features, and maybe do some hyperparameter tuning as well. So yeah, thank you guys for watching.